class last time is what's the strategy that you use if you have enzyme immobilized in a sphere. So we'll go through that. I also feel like you haven't had enough practice going through how to deal with batch reactors. And I'd like to give you a little bit more practice doing that. So if you look on Avenue, the midterms, the 2 midterms from 2013 are posted there. So you can feel free to practice those questions, but we'll particularly go through, I'll put up the question for the batch reactor that was on the midterm 2 years ago, and we can work on it in class and talk about it in class. The other thing I'm going to talk about is the paper summary assignment. I've just posted a revised version up on that, which is due at the end of the term. So because we're going into reading week, and I'm sure you don't have enough to do during reading week, well,
right.
we'll chat about it, and at least it can be on your radar. Any questions about any of that so far? Yeah. Okay, one other thing, actually, I know a bunch of the class is not here, but I was thinking of having an office hour during reading week on Wednesday at 10:30. Does that seem like something people would be interested in? I don't necessarily want to do it if you're not interested, but. How many people are actually going to be in and around campus during reading week? 3. So I'll be in my office anyway Wednesday at 10:30. So if you have questions, we'll go with Wednesday at 10:30. I'll post it on Avenue. If you can't make that time, you can go another time as well. Just you have to make an appointment with me because I won't necessarily be around. Okay, so we left off last class talking about what we would do if we had enzymes entrapped in microspheres in a CSTR. So we did a material balance. I think we did a material balance. I don't remember if I actually went through it. Okay. So the amount that comes in minus the amount that leaves now equals this effectiveness factor times Bm double prime. It's double prime because it's per volume of spheres as opposed to per area or per volume of liquid, times volume of particles. Substrate concentration be that we're looking at. If we're balancing how much comes in versus how much comes out versus how much reacts, how much is actually, so this is our effectiveness factor, how much is actually going to react? What does it depend on? Which substrate concentration does it depend on? We've got SB for bulk, which is how much comes out here. We've got S naught, we've got SS, which is what's at the surface of each particle. Which one should it be?
SS.
So you're absolutely right, Nikesh. It should be SS. Because how much, what the effectiveness factor does is basically take into account everything from the surface into the center of the particle. So it really should be SS. But now it becomes really difficult. It's possible, but it's really difficult to figure out what SS is in addition to what all the stuff going into the particle is. If you have a large enough particle, you could try and figure out SS based on the method that we used before, where you've got the diffusion through the static layer, basically. But usually that's not a really good estimation to make when you've got a microsphere. So what we normally do is assume that you've got them really well mixed, and that the diffusion resistance between the bulk and the surface is minimal. So we're going to assume well mixed. Therefore, SS equals approximately SB, and we'll put in SB. Now, I want you to recognize that that's not necessarily correct. If you're going to be complete and correct, SB and SS are probably not exactly the same. Essentially, what you're assuming is that the resistance to diffusion is much greater within the particle than outside the particle, and that assumption isn't going to make much difference to you. Okay, so that's all very well and good. You know, if you're given your flow rate in and your initial substrate concentration and the volume of particles, Km and Bm double prime, you should theoretically be able to calculate what the substrate concentration is coming out, or in other words, how much product you're going to make. Except that this depends on the substrate concentration coming out, right? So it's not as easy to solve as you might think, because if you recall, we had that handy little graph that you had to read off, where you had the effectiveness factor depend on the field modulus and on beta, right? So I'll just remind you, beta was Km over SS. In this case, again, we're going to assume SB. And we had our field modulus R over double prime. So in particular, our beta depends on SS, or given our assumption, SB, right? So we can't actually figure out what this is and without going to the graph. So that means it's analytically pretty much impossible to solve. You can't just separate out the variables easily and solve for SB, because this is a really complex thing that depends on SB. Okay, so we'll follow the standard steps. We'll assume SB. So again, SB will always be smaller than the amount of substrate going in, and it will probably be non-zero. Okay, so maybe a third of the amount that's going in is a decent guess to start with. Okay, then we'll calculate beta. In this case, we'll say it's Km over SB, and then we'll calculate field modulus equals R double prime over Km over DE, and then we'll use the graph. Find effectiveness factor. Again, just reminding you, if you've got a really big beta, it actually gives you a tan H equation that you can use instead of you reading off the graph, but it's still going to be a bear to actually analytically solve. So then use your balance. and then you put it back in here, calculate a new beta, a new effectiveness factor, and iterate on through until you have convergence. Does that make sense?
Is that to the rth root or r times?
R times.
Oh, okay.
Yeah, sorry. Times.
Right.
I'll put it a little lower. R times. Good question. It's important, a very important distinction. Okay, so does that make sense as a general strategy to solve these sort of problems? I mean, this is what you'll have to do. It's much easier if I give you SV and ask you for the volume of particles. That's a really straightforward question to answer, right? If you know what your bulk substrate concentration is, you can go through one time, figure out what your effectiveness factor is, one time, put in all your stuff for there, and then volume of particles falls out really easily. But if I give you volume of particles and I give you initial substrate concentration and ask you how much product comes out, then it's a lot uglier and you have to go through this iteration process. Everyone good with that process, the idea? So the short story for both of the immobilized enzyme type of questions is that if I ask you for how much product comes out in a CSTR using an immobilized enzyme, it's a fairly complex question to answer. So that's what your assignment asks you to do in both those cases. You have to go through that. I mean, there are other ways, but that's a basic process that works. Everyone good with that? Makes sense? Awesome. Okay, so now I'm going to talk, we'll finish the class with the example from the midterm from 2 years ago, but I just want to talk a little bit about the paper summary that assignment that I just posted. I mentioned it very, very briefly in the first class, so now I'm going to actually talk about it in more depth so you know what I'm really talking about. So it's not long, maximum 500 words. But this paper summary assignment is a teeny bit different from writing an abstract, and it's a bit different from, say, the assignment you did in 2G that was for a very general audience. The purpose of doing this summary is twofold. One is to get you, again, to figure out what the important parts of a paper are and write it in relatively non-technical language that really highlights the significance of the paper. But the other is to get you to see what a paper looks like that has had a big influence on the field. So oftentimes we're always looking at the most recent paper that's been, published in the last year or two, and what's the most exciting thing that has happened very, very recently. But it means that it can be difficult for us to have perspective about what a paper looks like that's likely to change the field. So what is a paper that is going to have a big influence? In this case, what we're doing is we're looking at papers that are historically quite old, but that have had a big influence on the field and that have really changed the way that people have approached the field. So we're looking for ones that are in the purview of this course, so biotechnology related. I'm pretty open if you want to also include ones that are relevant to tissue engineering and biomaterials, just because I like them. But I've given you a list of, I think, how many? 21 papers from which you can draw that are suggestions, but I'm also willing to take other ones. Now, all of the ones that are in there have had a pretty big influence on the field. If you're thinking about another one, you have to pick something that has had at least 100 citations and is not a review paper. Okay, so we're not summarizing review papers, we're summarizing research papers and ones that have had a big influence. And the way we're going to easily say had a big influence is it's been cited at least 100 times. Okay. the purpose or the audience is, if you are working at a biotechnology company, the audience is your boss. So your boss may not be a scientist, but is cognizant of the field. So they understand what's going on generally in biotechnology, but they may not be ready for, like if you put in an equation, it's not appropriate. You need to describe what's happening in the equation. You can't have any figures from the paper, charts from the paper. The idea is you're sort of going big picture, and you're describing what's in the paper, but you're also describing why it has been important in the field. So I don't want to just see, clearly this was important in the field because it's been cited 163 times. What I want you to do is actually go and check out what some of those citations are, who are the people who cited it, and where have things gone as a result of the discovery that was made in that paper. Does that make sense? So it's not that you have to read all 163 or 3,500 citations. I think one of the ones that I added had over 3,000 citations. So don't go read all of them, but just go through a sprinkling of them and try and see, even just the titles, try and see where it looks like things have been going as a result of the thing that was reported in that paper. Does that make sense? Generally? Any questions? So I would say that's the thing people did worst last year, is they didn't talk about what the consequences were of the paper, what the result was of the paper. So they did an okay job of saying what the crucial discovery was of the paper. In some cases they went a little too technical, in some cases they clearly didn't understand the paper fundamentally. They say, so for one of the challenges they do for PhD students now is they call it the 3-minute thesis. So you should be able to explain your complicated PhD thesis to a general audience in 3 minutes, and that's your test of whether you really understand what you're talking about. So here, you may need to actually go and do some extra research so that you really, really understand the paper in order that you can explain it in more or less layman's terms and really understand what the key finding is of the paper. What's the really important thing that they did their research on? Why have all these people cited it? What's come from it? Any questions? So it's due at the end of term, December 7th. But don't leave it till the very end. Oh, the other thing is, if you want, so I'd like you, please, to go on Avenue and on the discussion board, because if you all email me individually, it's very easy for me to lose track of who's doing which paper. So on the discussion board, post which paper you would like to do, and if you have a specific paper that you're interested in doing, email me. You don't put on the discussion board initially. Email me to make sure that it's okay, and then once I've said that it's okay, then put it on the discussion board. I had a bunch of people last year email me repeatedly with review papers or with papers that weren't cited enough times. So in the instructions, it's here's how to ensure at the bottom, here's how to ensure you do not pick a review paper, and here's how to find out how many citations there were for your paper. It's actually quite easy to find the citations out if you go through Google Scholar. It's just right there. But there's Web of Knowledge also tells you how many citations there are. PubMed tends not to, right off the top. So it's a nice way to do your search, but it may be a harder way to find out the citations. Okay, yeah?
So 2 people can't do the same paper?
So I'm going to say 2 people can do the same paper. So if you're the second person, that's part of why I'm doing it on the discussion forum. I only gave you 21 papers. So if 2 people want to do the same paper, I'm okay with that. But go to the discussion forum, and if you're the third person looking to do that paper, you're out of luck. And it's all first come, first serve. Okay. And again, if you find that there are none that really interest you or the ones that really interest you, that you're the second person, then you can go and find a paper that really interests you outside of this list and just check it over. But by November 7th. Okay, so I want you to have picked your paper by November 7th. I think I said November 9th. November 9th. Okay. I'm sorry I changed format of the papers. It's because I added a bunch of synthetic biology papers at the bottom. So if any of you are really interested in synthetic biology, papers 16 to 21 are all about synthetic biology. So using some of the modeling tools that we've been talking about in this class to try and create organisms that do specific things. So some people have been doing metabolic engineering to make higher yields in their cells. Some people have actually been trying to use cells as little computer systems with like AND gates and NOT gates. So those are some of the key papers that have been the genesis of the synthetic biology field. I just thought I'd throw those in as a new set of papers that might interest you. Any more questions about this? I do want to make sure everybody does it well. So don't, please, 500 words seems like you can just knock it off in no time. You can, but you won't get a good grade if you do that. Because you won't have the time to go in and see which papers have cited that paper and really figure out where it's gone in the field. Yeah.
You still have to post the paper choices because they're not there yet.
So on the discussion board, post which paper you're planning to do by November 9th.
Oh no, but like you said that there's a list of papers to choose from.
So the list of papers, I haven't posted. If you go under paper summary assignment on Avenue, it's under content.
Okay.
The second page of that has the list of papers.
All right. Okay. Thank you.
Yeah, and I did that about 10 minutes before class. Any other questions? Okay, so now we're going to just spend the rest of class, I can't promise you'll get through it, but the rest of class going through the batch reactor problem from 2 years ago, the midterm 2 years ago. And again, I will say that the biggest problem people had with batch reactor problems is that they forgot to keep everything in variable form before they integrated. They put numbers in that weren't constants. Okay, so I'll read it and just write down the key parts. So it's a batch reactor. So with a volume VL is used to perform an enzymatic reaction. At time 0, S naught is, all right, the concentration of substrate is S naught. It's substrate inhibited. Okay. It says use the textbook equations developed using rapid equilibrium assumptions. So that means you have to go and look up what the substrate inhibited version of Michaelis-Menten kinetics is. And then it says if the initial substrate concentration is 10 moles per liter, Km prime, note the prime, because that was developed using rapid equilibrium, 5 moles per liter. Ks is 1 mole per liter. It says when will the substrate concentration drop to half the amount? So T for S over S naught equals 0.5. Okay, and it says as the initial substrate, so that's sort of one part of the question. And then as the initial substrate concentration approaches 0, comment on how this calculation relates to the time it takes to use half the substrate for a non-substrate inhibited reaction. So compare times with just a hint for answering midterm questions for me. If I say, in this case, I did not say be quantitative, so I'm just looking for a general explanation. If I say be quantitative, that means you have to use an equation and actually calculate something. So if I said be quantitative and given you a, compare time for it to, drop to 90% or at 1/10 of the amount, then you would have to go and calculate what it was for 1/10 of the amount in both those cases if I said be quantitative. If I don't say be quantitative, you just have to comment.
So on this question, we would need to do
Just
the
have to
equation for
comment.
non-substrate.
I mean, you could say, check out this equation, the consequence of this will be that, and then say it in words, but you don't have to use any numbers. Okay, does that make sense? Okay, so I'm gonna say get started, and I'm gonna wander around and chat to people about how that works. Oh, ouch. And if you walked in late, I've got your paper, your assignments as well. So. Sorry? Yeah, you guys need yours. Sorry? Last name, other sort of.
So what are the substrates?
You look pretty fast.
Yeah, that's why I saw it work on that.
I'll make sure we in out of it. So maybe a little bit later, it'll get marked. But that means it would be probably after 4.
Yeah, I read the tops and at the end of my 620, and then I saw people drop in Dropbox, and then after I looked back, when I looked at my back, and I was like, and I saw the 4 Dropbox.
Yeah, that's because
I signed up.
secretary is here at
Yeah,
and I don't have the key, so I can't go in. So if you want to get it to 620, then.
Oh, so which work? Yeah, I didn't see that.
There should be 4. And I've only got 3 posted. Because last year I ran out of time, so I did the 4th as an credit practice. No, well, it depends if I get through all the material. So hopefully it'll be 4.
What's KS?
Yeah, so yeah, right. So yeah, I honestly we haven't looked at the Dropbox.
Yeah, so I figured that would happen.
So we'll make sure.
When I read it, it's the bottom half of it.
Rookie mistake.
I'll get PM. Yeah, it is.
So you have, so it's so you take TV over DS.
Are you guys getting up?
So you have your, this is,
Google shit. Because then you're just waiting for other people to pay. It does take a lot of time. But like, it's fine.
oh no, this is right.
But then again, like if we all,
Are people living right there?
then we just partner up and then part up and it's like,
That's
fine.
Wait, let's try it.
I think I have our just like one house, right? So I'm not gonna. Yeah, that's the other thing.
But you can run as max. Oh, and so VM is for
Which is the other reason it doesn't make sense. chest that he's spawning.
But you can get tomorrow.
Right down here.
They'll also be in the.
Well,
Brian's supposed to know this answer.
So we will do what we did. Okay, so we'll do chest and chest. You wanna go one text?
Can we write out a reaction?
Substrate inhibited, it'll be past that, I think. Yeah, this is what.
Go pull it up unless you have it. You have it. Is that from my 3D case?
Yeah, so. Or down for.
Okay. From earlier.
So this whole thing here is KS, right?
Yeah.
Substrate.
You have extra time for returns.
Yeah, I'll be notice comes through the mail or email.
Only maybe this, maybe the paper things, I'll speak beforehand.
That was amazing. Awesome. One on Monday will come through in the next few days. I think it's the same thing.
It is.
Yeah.
No,
It is the same.
We just different occasions. We're like,
So this midterm question actually is posted, if you go on Avenue or content, I'll highlight it.
Yeah,
in the
that's
newsroom.
One Direction, that's
But
KS.
under
That's
content,
little
there
K.
are extra questions. Both of the 24.
wait a second. All right. Wait. Oh, I just thought.
Yeah, like I can practice.
Perfect.
And then like the action in terms of like stuff like
How inhibited we are.
like in terms of like.
I can't promise that it'll be on my phone, but it's not a just example solving. But if you're comfortable with the assignment questions and comfortable with the questions, then like I can conceptually go with them, then
If it's less than one, then it's not.
but yeah, it's not gonna be like,
Oh, yeah.
you know, here's the exact back reaction with, substrate inhibited, but I just use it as a.
Oh, okay, no, I'm not expecting that, but like just something like along those
There'll
lines.
probably be a batch question, there'll be an enzyme question, there'll probably be an immobilized enzyme question.
Three questions.
Yeah.
I think it's gonna take. But who, no, we sit on the class.
I've seen it.
It's like the condition of whether or not you do it. Oh, wait a second.
For all of our equations that we have, use KS too.
Yeah, I don't explain this.
It's just a different.
Why? But
It's just a slightly different nomenclature. We're
How?
still seeing.
so that's big KS, that's equal to your constant.
Okay, after
So,
because it just, I
your,
thought you were sending me like.
so I guess the PS2 would be the same.
I'll check it, those are my notes. I'll check
In my notes, the KS2 is the rate constant.
Because I heard.
So that's
P2
little
is
KS
your-
too.
Oh, did you send me the one that we
Yeah.
had on?
Yeah.
And all
Yeah,
of
so
our-
that'll be your, that's the equivalent to your
I heard.
PS here.
So, why?
So can you
Because
guys
that's
start
your
with,
constant.
Sorry?
can you not give me the direction of where you're going with this?
Well, I want you guys to try to think about it.
Yeah.
Yeah, so like the lecture is a subset
Little
of
KS
Yeah.
So.
How do you know? How do you know that?
That's your limits.
Well, because this
So what's rate?
One of the intermediate.
So we have, so that is like, they say,
Yo, the short answer is hard. Multiple choice. Yeah, the only reason we did not fix it.
Alright, so in that case, we still have max.
No. So that's where everybody goes wrong, and that's exactly why I'm doing this, is because I don't want you
Like
to
the way
do
he
that.
got it.
So what Carl, so the first thing that we were talking
But
about
I'm
is,
so glad I got an idea.
any batch reaction, maybe I'm not
oh, wait a second, this should be like.
See, the problem is you have a new problem.
Yeah,
I mean, it's that, like-
rate, the other way of saying rate is
I don't know how to say it, yeah.
right? So,
Changing the
rate
concentration.
is the change.
What equation is it?
So that's, yeah, so it's actually,
Yeah.
minus ds by dt, truthfully.
I'm sorry, my phone's like direction.
So then you know your rate in terms of s. So what Carl was about to do is say it's just 10 minus 5, and then integrate 10 minus 5.
Why?
But you would be surprised how many people do that. Like everybody does that.
But we have this equation.
But you have that equation exactly. So you have the equation.
There's a batch
S.
kinetic things for electric fries.
Yeah.
Yeah,
So
so we
then what
just
you're
gotta
gonna
jump
do
to
is, what you're gonna do is integrate that before you put any numbers in. And now what you got is
This big
your
copy here is like a hell of a.
differences.
Wait, is it not the batch? What equation is it? Is
Are we
it
doing five? So, our fine, where our fine says, did I check that? Use this equation or?
Just use the whole
Yes,
thing.
over E is.
That one?
Actually,
So what
E is
is
equal to negative.
Oh, substrate inhibition.
Because
Is it electricity?
rates define that like the
Yeah.
product, so.
That was must have been second.
So that is what
So you want,
Yeah,
so
that's
you
fine. I mean, if
so
it's
you want
really a
keep,
bottle
so you want,
higher.
basically you're gonna.
So usually you wouldn't observe
Because
anything.
here,
Yeah, so.
let's still have a lot higher, right? It's really not.
Here, you're fine.
Plus this.
25. Grades.
So when I did it, what was it, page 5, you asked this.
Where did you use this?
Where
You can do deletion assistant.
Exactly. Why do you need a position?
Well, you can do it.
went through issues.
Yeah.
Sergio,
Yeah.
I think that, the case. Alright, so the next
Because like,
Yeah, the debate is what he's doing.
Yeah, you know what I'm doing, and then most people show up.
What happened?
We did meeting minutes, nothing really happened, we did introductions.
Yeah, because I have class.
I guess just sitting in the corner.
I just
Everyone looked at him, it was his turn.
So I was like, oh, alright, sensitive. When are we gonna start
We
like?
looked at the card.
They want to go anywhere.
They want to go
Does
to
anyone agree with that?
We're like, okay, oh, then fuck our budget.
how is it to make the card? Is it just like
Don't go with the.
But also,
If
if
we
you
don't
don't
join
use
that,
Oh, I see.
like it seemed interesting.
Did it really?
This one.
Yeah, you
Like
can.
you did a bad job, like,
I did
but like,
really
it
bad.
didn't seem interesting.
Oh,
That's
it's
for
like,
everything.
could use that.
Yeah, that's
You
just.
need a
you know,
social-
making it such a
Alright, Jay.
substrate concentrations are.
Dude, all the
covers the
presentations.
entirety of
Just like you're the marketing guy.
like from time zero to
Yeah,
time whatever.
I have to do it. Yeah, we will.
So-
That means you're the big one for every meeting.
Okay, so it's not, yeah, we should just cross up.
Yeah.
So is it in our case though?
Or ds, minus ds by
Did you solve this? That's the equation that worked, right?
So.
I don't know, and my fear.
This is dependent on.
It's Sergio. It's Sergio's next.
So if you were in a different circumstance.
Sergio, do you want an assistant?
Basically, you just automatically do all this shit.
No, it's called
Can I be your assistant?
It's not official, but it's just like,
Yeah.
I did a table.
Co-president.
This is a way
What else? What else are you doing?
So I'm just gonna divide it all by my S.
You make business cards,
So
right?
it's, yeah, if you go back to your notes.
What? Are you serious?
And you
I can't?
pull up what the equation is.
I wouldn't do shit though.
I really want you to make sure that people have the concept of how to. Yeah, it's like 5 podcasts.
Yeah.
7 podcasts ago.
So like,
Figuring?
yeah.
Okay, so did you find the rate? There you go.
Yeah.
Okay, so now, yeah, don't worry about that part yet.
Oh, okay.
Worry about so anytime that you're dealing with batch stuff and how much time it takes, the important thing is to remember what rate it is in terms of TS by DT. Rate is just the change of product, the increase of product time or the decrease.
Mikey, it's not hard to run numbers through a scan.
So minus
Or like
TS
just run the
by
scan trouble sheet.
DT. It's all that.
We have.
You just don't have, well, you're gonna have S.
Yeah, so we just have to solve for, so we use this solve for S.
So you're trying to figure out what T is, right?
Okay, so then we'll do sub that in.
So the important part is when do you sub stuff in?
So.
How do you solve in terms of T? And then, yes, yeah, yeah.
Right, but there's no time to enter.
But my experience was
that's
that
actually
even when people had done the assignment question, they didn't fully get when they, like, that rate was TT minus TS. And don't put the numbers in before you do it.
Or is it still
Really remind.
Yeah, that's always like a little tricky.
So, yeah, it was one of those things where, like, from my point of view, it wasn't tricky at all, but then the results were that, gosh, people found it really tricky. Yeah.
Okay.
Yeah, that's what I did.
Let's just up on the next one.
Because that's
Okay.
Do the assignment.
So what approach you guys on?
Yeah, I feel like we do this as well.
I think it's so much easier. What time, how long it takes for the substrate? Okay, so it looks like you've got the wage one. And then that one right there. So that's already so we'll use that, use that, and you equal that.
But, okay, and then you just divide it, derived in terms of,
Then you separate out your variables, so you put all your S's on one side and.
That'll be the one I was
And
asking.
then
But like,
integrate
okay.
before you put numbers in. And, but your limits of integration before you put the numbers in.
Yeah, so you just integrate it, like, okay, integrate it normally and then just
value of that.
And then that'll tell you what. So, yeah, just pull, you have one assignment question, but pull really good, so that's why I wanted to work with that.
So is this, this is the one, which is
Yep.
Is it, are you trying to compare these two?
Ultimately, at the end, you're gonna compare those two, but for your calculation, you actually do that. So you put all the S's on one side and like pretty much nothing else but T on the other side. It ends up actually not being a very hard integration. Essentially flip that upside down.
30 people got that covered, right?
The big take home message is rate is ds by dt and integrate using variables, not numbers.
Like remember we had
Remember that?
special like
So if you see that in time, then you have a rate that's ds by dt somehow. Yeah. So also, you're right, dp by dt is also equal to minus ds by dt.
Are you sure? No, you know, you guys haven't seen that, probably got like 5.
So this is the problem, you're asking your
You still have it?
Yeah, so that's actually why dp by dt is equal to minus ds by dt. So if you do the conversion. So that way, that's not gonna change it, that's where the. So do it, yeah, do it, that's a great.
It's always
CRNA will trace because
Yeah.
priorities items.
Make sure you don't have stuff that is all like dependent on it.